All right, so lastly, we're going to talk about the bijective function. Now, a bijective function is a function that is both surjective, which is onto, and injective, which is one-to-one. All right, here's a note. The inverse of a function exists if and only if the function is bijective. So we can only find the inverse of a function that is bijective. We can only find the inverse of a function that is what? One-to-one, which is injective, and surjective, that is both one-to-one, which is injective, and surjective, which is a function in which every element in the codomain is the image of at least one element in the domain. In this case, it must be only one. All right, so let's have a look at example 15. Example 15 says, given that f of x is equal to 7x plus 2, show that f of x is bijective. All right, so example 15 says, given that f of x is equal to 7x plus 2, I'm to show that f of x is bijective. All right, for this one, I'm only going to use the graphical approach. So for the graphical approach, I need to draw a sketch of the graph. Now, f of x is equal to 7x plus 2 is a linear function, and the graph of a linear function is a straight line. So I'm drawing my x-axis and my y-axis. The graph cuts the y-axis at 2. It's a positive. The gradient, which is 7, is positive. Therefore, from left to right, the line slopes up. This is so this is the y-axis. This is the x-axis. This is the origin. This is a graph of f of x is equal to 7x plus 2. Now, every horizontal line that I can draw through this graph, or every line I can draw through this graph parallel to the every line I can draw through this graph parallel to the x-axis will cut the graph. All right, so let me just make these statements. Every line every line parallel to the x-axis that can be drawn will cut the graph at most once. Therefore, f of x is injective. It's one. Now, every horizontal line, every line drawn parallel to the x-axis will cut the graph at least once. Therefore, f of x is surjective. Therefore, f of x is bijective.